goofy week once again this week. No Friday again. So, which is fine. Just takes away. Luckily, the infinite geometric sequences and series, we can handle that in a day. Very easy concept to wrap your head around. So because of that, your unit test is going to be on Thursday of this week. So today we're going to handle infinite geometric sequences and series. Then on Wednesday we're going to review. I think I gotta look. I'll look today at the end of class, but I think I got a little different review style, kind of like a trivia game review style type thing for this one. But I gotta remember if that's what I had set up for this or not. And then Thursday's the test. Friday, independent learning day. So we'll go with that. Then when we come back next week, ACT doesn't affect us. So you don't have to worry about that on Tuesday. But then we're going to start conic sections next week. And that will take us, conic sections will take us for the remainder of the semester. Okay? So yeah, conic sections is a fourth quarter, one topic quarter. Plus we got the final in there. All right. So, infinite means we're going to infinity and beyond. Just like my guy Buzz. Okay. Talked about that already. Just putting it in writing there for everybody else. Forget that I had. Oops. So, let's say that I have a geometric sequence. Let's say, give me a number, any number. 4, okay? So I heard 4. So let's go with the sequence is 1, then 4, then 16, and so on and so forth. Right? Because my R value is 4. What's the sum of the first 3 terms? 21. 16 plus 4 is 20 plus 1 is 20. Okay. So the sum of the first 3 terms is 21. What's the sum of the first 4 terms? What would that 4th term be? 64? So what would the sum of the first 4 terms be? 85? Okay. What would the sum of the first 5 terms be? What's the next term? 256? Can I find the sum if it goes to infinity? Why not? You can, but you gotta give me a better reason than just because it's infinity. No. Because we're gonna find the sum of infinite geometric series today. And they don't end either. What's happening here with all of these terms? Okay, we'll pause. Let's go to a different thing. Let's go with a new sequence. 8, 4, 2. What's my R value? One half. Okay. What's the sum of the first three terms? 14. What's the sum of the first four terms? 14. Sum of the first five terms? 15 and a half. Because we went, so the next one would be 1, next one would be 1/2, next one would be 1/4, right? So what's the sum of the first six terms? 15.75. Yeah. Talk to me about terms in the sequence. Blue versus black. Talk to me about blue versus black. Even more. Be as specific as you possibly can. And I can tell you, it is the answer that I'm looking for is as simple as you want to say, but you think it's not right. The blue numbers are getting bigger. The black numbers are getting smaller. Right? Okay. So why can I find the sum of the black, but I can't find the sum of the blue?
It's exponentially getting larger, which means it becomes exponentially harder to make the sum.
So each term is getting bigger by a factor of r, right? Okay, so it's not getting smaller, it's getting bigger and bigger and bigger. So it's almost doubling, right? In this case, it was almost quadrupling our sum total every single time, right? Whereas here, what's happening with the term? Just put your hand.
I was going to say, is there, can we make an estimate?
Close. As the black numbers, as we go out farther in the terms of the sequence of the black numbers, what are those numbers going to be getting closer and closer and closer and closer and closer and closer?
Closer to zero.
Closer to zero, right? And what happens when you add zero? Nothing changes, right? When you add zero, nothing changes. Okay? So, for what R values do infinite sums exist? The R has to be in between -1 and +1. If it's outside of that range, we cannot find an infinite sum. Okay? Because if it's outside that range, then your terms are going to be getting bigger and bigger and bigger and bigger every single time. Okay? So the sum, or the R value, is going to tell you if you can find the infinite sum. So if your R value is in that range, then this is the formula for the sum of the infinite series that you have. So all of the terms in that series we really only need the first term and the R value. So our black sum, or our black series, was 8, 4, 2, 1, 1/2, 1/4, ... Okay? So the sum, we said it's got an R value of 1/2. The sum is going to be my first term, 8, divided by 1 minus 1/2. Well, what is 1 minus 1/2? 1/2. Okay. What is 8 divided by 1/2? 8 divided by 1/2. 16. So the sum of this black sequence right here, shade, shade, shade. So the sum of that sequence right there, if we take all of the terms to infinity, is 16. Because each term is going to be getting smaller and smaller and smaller. If you think about it, through the first 6 terms, we only got 0.25 left for the remaining ones to infinity. Okay? So, keys to look for. 2 different things you need to look for to determine if it's an infinite geometric series. First key is the 3 dots at the end of the sequence. Okay? Or at the end of the series, the 3 dots there, that means it's going on forever and ever and ever, and you're going on to infinity. Other one, the infinite sign on top in the sigma notation. Okay? That means it's infinite. Okay? So, first thing you need to find is you need to find G sub 1. How am I going to find G sub 1 given sigma notation? Put in what? Nope. Put in the bottom number, not n. The bottom number. So what am I going to plug in? 1 in place of n. 1 minus 1. 1 minus 1? 0. 1/4 to the 0 power. 1 times 3. 3. So my first term is 3. Next thing you got to do is you got to figure out your R value. What is my R value given this sigma notation? 1/4, because it's what is the power, what value that has the exponent on it. Is that R value in my can-do range? Yes, it's between -1 and +1. Okay, it's less than 1. Yes, so we can do it. So the sum of my geometric series is G sub 1, which was 3, divided by 1 minus 1/4. 1 minus 1/4 is 3/4. 3 divided by 3/4. What? 4. Our old pal, keep, change, flip. And dividing by a fraction. Find me the sum, if it exists. If it doesn't exist, then you put sum does not exist. First term. All right? 1. R value. Is that in my acceptable range? Yes, it is. Okay? So the sum then is going to equal my first term, which was 1, divided by 1 minus negative 1/2. 1 minus negative 1/2. So 3/2. That gives me a sum of 2/3. Why I keep change flipping. Fraction form. Always about fraction form. First term. One. R value. 3/2. In my range. If it's not in your range, that sum does not exist. Okay. Gotta be in between -1 and +1. Okay. All right. A golf ball is dropped from a height of 9 feet. After each bounce, it rebounds to 75% of the previous height. Find the total distance the ball will travel. Okay. So it went down 9 feet, right? Then it went back up. How high? What? So how high? Six and 3/4 feet? How'd you get that? Okay. Then what happens to the ball? How far does it go back down? 6.75 feet. Then, how high does it go back up? How high does it go back up?
then same amount. And so on and so forth, right? Okay. Find me the total distance that that ball will travel. I got an answer. All depends on how you do it. Because what are we trying to find? What are we trying to find? Total distance. So what is the total distance going to be? That would be included, because the total distance is going to be the amount of time the ball is traveling down, right? And up too. Yeah. So total distance is downs plus ups. So give me one strategy that you could do. No, okay, yep, and add 9 at the end. Yes, you could do that. Okay, so that's one strategy. You could set up your infinite geometric series with 6.75 as your first term, then multiply it by 2, and then add 9 at the end. Okay? Another theory, another strategery. Another way of finding the answer. Okay? But that only gives me the total for the downs. Yep, exactly. So we could do a blue infinite series. Yep, where 9 is our first term, 0.75 is our R to find that sum. Then we'd have to do a green one, 6.75. R is, as your first term, R is 0.75. Find those, add those two together. Yep, that's another good strategy. Anybody else got another one? Other one is you could do one complete cycle. So here is a down and an up. Here is a down and an up. You could add those two together, and that be your first term. And then this is going to be 0.75 of that also. So, yeah. Yeah. Either way, so let's go with the first one that we said. So you said what again here? 6.75 was our first term. Our R value was 0.75. And so we said then that the sum there was going to equal 6.75 over 1 minus 0.75. So that's 6.75 divided by 0.25. gives me 27. Okay, then twice the sum plus 9 is what you had said, right? Because that then accounts for, so that would gave me all the ups, then the twice the sum gave me all the downs, add 9 at the end gives me that. 2 times 27 is 54, plus 9 is 63. Yes? Yeah. 15.75 as my G sub 1. R is still going to be 0.75. Sum is going to be 15.75 divided by 1 minus 0.75. 15.75 divided by 0.25 is also 63. Sum of the downs, if we went Mr. Clifford's way, sum of the downs was 36. Sum of the ups was 27. That's the other 63. Okay. Homework this week is the Unit 7 review. It is here. I point out the fact that the answers are at the bottom of the back side, which is why the answer key is not posted on Canvas yet, because the answers are right on the sheet. And then I say that at some point in time, Mr. Roth is going to post some additional problems for you to practice on, but those additional ones we will not be collecting, just so you know.
You got fired with food.
Well, you can do those all in one trip.
I have plenty of stars that I won't be back until.
Here's Mr. Roth now.
Holy cow, it's warm in here.
It is not cool, no.
Yeah, I was gonna say that.
We've been talking a lot, huh? A lot of hot air.
Reviewed it. But, I mean, there will be review problems and the like, you know what I mean? I like how your care and therapy is,
So when I forgot how you would add these, so I just add one and then do you have that?
edit. Big one. Highlight that to there, up to there, yep. I'll ask. Then I just copy this. Okay, so school.
You're good.
I think it's.
Okay, so,
You have heard some answers?
no, but,
Then one of them's not, we'll figure it out.
but hear me out.
I'm listening, he's not.
I'm not.
Cause it's negative, or you get the square root, right? So it could be negative or positive, or the cube,
Even root.
Square root of 436.
so it could be. Yeah, right, right, so, but then the G of one is two divided by your ratio. So then if it's even, then it'd be even, but if it's odd, it'd be odd, you know what I'm saying?
Yeah.
So then it could be,
I think that's not part.
if you divide by an even number, or, I mean, if you divide by negative numbers, that's what it is. Then your G of one would be negative.
Oh, okay, so that's why they test you.
Yeah, yeah.
Correct.
So then you need four equations?
No.
Why? But what about your G of one? Because that could change, couldn't it? So they're either both positive or both negative?
Do you want, so do you wanna do trivia? And then it's. So they ask like question number one, and they have to do this, they gotta find that.
Well, this,
And then they get to determine how many points they wanna put on each one. So like they gotta,
Oh, I see, so then it's 1 through 1 through.
so they get 1, 3, or 5 in the first round,
Oh, okay,
or in the first half.
okay,
So if they think, yeah, I got this one, I know this one, I'm gonna put 5 on
before they answer it.
it before they answer.
Do they see the question first?
Yes. No, yeah, no, yes, I see the question, and then they get to pick what they want to put on before I reveal the answer.
Oh, in any order, so one has to be, oh, I got you.
So, so we pop this question up. Have you ever gone to trivia like that?
I have, but I thought it was, you answer the question and then you decide whether you want to do 1 through 5 or you put
Well,
it-
you see the question, so like when you submit the question
Uh-huh.
in to wherever,
Uh-huh.
then that's when you determine how many points you want on.
Oh, okay.
And so if
Yeah,
you and I are partners, we're like, and we're kind of bickering about it. Okay, we're not, we'd be a 1, but then we're done with 1 for that round.
Yeah, exactly. So they can answer the question. and
Yes.
then decide if it's 1 through 5.
Yes, yes.
Okay, gotcha.
Yeah.
Yep.
Okay.
How long is this going to take?
It's close to an hour.
Oh, you think so? Okay, because my kids are on the way. They have time.
Well, I mean, it depends on if everybody's got, like, I would say like, I mean, some of them are finding rules and,
Yeah.
I think what I did like a minute and a half
Right, yeah.
of time to work.
Yeah.
And there's, so there's.
So there's 3, 6, 7 questions. Right?
So there's 9, 3 topics.
Oh, you have a whole bunch of topics.
Yeah. Yeah, so there's,
Oh, yeah, there's 6 plus a half.
Yeah.
Third and fourth.
yeah.
Bring that down to.
Yeah, so and then there's 3 questions on geometric, and there's 3 questions on infinite geometrics. And then there's halftime. And then there's 3 more questions on infinites,
Yeah,
3 more questions on geos, and 3 more questions on mathematics. I think it was a good 45. We could take out the halftime
I'm just
question.
gonna take out, or take out, merge 2, do 2 rounds per half. I'll take a look at it. I'll print it and maybe we,
Okay.
because, and my kids just want.
We could do work time too.
No, I think it's better doing this, because actually, and they were fine, they were like, no, they like the idea of having more problems.
Mhm.
They do like that
Mhm.
idea, that's all.
You just gave me the blank rule now.
Yeah.
Think-
Yeah, maybe we'll not end the 4.
And we can change we can drop that down
Yeah.
to 10. Yeah.
I'll take a look at it. Like,
It's in your bag. It's in that